we're going to keep talking a little bit more about pointers and stuff. But before I do that, one thing I want to revisit is for loops, because I've been noticing in a lot of people's code, the way that you guys are doing a for loop is, it's technically okay, but it's just bad practice. So what I've been seeing a lot of you guys doing is something like this. Okay, something like that. So this is just some random loop. It doesn't really do anything interesting. But you declare I outside the loop, okay, and then you set the initial value here and the termination condition and so on, okay? So that's bad practice because it means that I, when the loop finishes, I is still in existence, okay? And as such, you can't really use it for something else. Okay, now we typically only ever use I for a counting variable and integer, but how do you know that you wouldn't need to do like a different type of integer or something like that later with I? Well, you can't change his data type really. Okay, so what's better to do instead of this is just don't declare anything outside the loop for the counting variable, okay? But do it right there, okay? And the reason that you want to do that is then you can come along and have a second loop, okay, that also uses the same letter, okay? But when you declare it that way, the I goes out of scope when you exit the loop and can be reused later. It's a different I, right? So this I here and this I here are not the same I in terms of memory and stuff, and that's just better practice. Okay, so it works if you do it the other way. Okay, and there are plenty of times you want to declare variables outside a loop. Like for example, let's say I was adding things up in a loop, and I might say sum equal int sum equals 0, and then do something like sum plus equals I, right? I'm adding things up, and then at the end of the loop, the value of the sum is a known quantity, right? So I have to set it to 0 initially, and I should do that outside the loop because otherwise I'd reset it every time if it were inside the loop, okay? So does that make sense? Right, so just think about where you're declaring things, but for the, um, for the, um, for the for loops, this is the better way to write them. Okay, like I said, the way some of you guys were doing it worked, and it probably compiled fine and executed fine. That's all cool, but it's just kind of not good practice. Okay, okay. So I just wanted to talk about that real quick to start, and then what I really want to hit more today are pointers. And which one were we doing last time? Strings two. Okay. Um, okay. So I want to hit pointers and talk about really what you're doing when you pass things to a function. The only types of things you can pass by value, okay, are integers, characters, um, floating point numbers, Booleans, basically anything that can be encoded in 64 bits or less. Okay. Um, but you can't do that with strings or arrays, even if it's a really short string. Okay. So you could have a string of, say, 4 characters. Yeah, that would fit into 64 bits, but you can't actually pass that by value in C. You're really passing it by reference. Okay, so that's kind of what I want to talk about here. Um, and in particular, let's just take this function that I've got here. Okay, So we wrote this function that did uppercaseifying just as a demonstration, okay? Nothing particularly exciting about it, okay? But we just said, okay, we set up a counter, and while the character that we're currently looking at is not the null terminator, if it's between the lowercase a and the lowercase z, uppercaseify it, otherwise do nothing, and then just move on down the line, okay? And we saw it worked, okay? Nothing grandiose there. Okay, so what I'm going to do to start here is I'm going to write a second version of this function, but the syntax is going to look a little bit different. Now, it'll do the exact same thing, okay, but this will give us an opportunity to kind of get into the discussion of pointers, okay? Okay, so let me call this, remove some space there, and let's do uppercaseify 2. Okay, so we'll do void uppercaseify 2, and this will take in a, not the name of a string, but this time it'll take a pointer to an input string, okay? So the star there declares that this is a pointer variable, okay? So what's a little bit funny about this is, okay, it's a pointer to a character, okay? And in the case of a string, what character should we be pointing to start? 1 second, man. Just the first character, okay? So that's what it'll start as, yes. Okay, a pointer, right? So what is a pointer, guys? Yeah, it's the memory location of an object, okay? So a pointer variable is just a thing that's storing the location of something else. It points to it, okay? So what's the analogy that we use for this? It'd be like your mailbox number, right? I could say, all right, your package is in mailbox number 7. 7 is not your package. That's the location of your package, right? And if you wanted to access that package, you'd go over to box number 7 and open it up, and bam, there's your thing, right? So the pointer is like the number 7, okay? It's the mailbox number, or in our case, the address in memory where a thing is, okay? Or in the case of a string or something, where it starts, okay? So the star, when you declare a pointer, indicates that it is a pointer to what type of object? In this case, a character. Okay. Now, what's funny about this is, so if you think for a moment, what memory addresses are how big on this system? What does the memory address look like on our machine? It's a 64-bit number, right? Because our memory space has 64, well, 2 to the 64 mailboxes. Okay, it's a 64-bit machine. And so even though it looks like I'm declaring a character, this object, this pointer, is really a 64-bit number. Okay, in the same way that number 7 is a number, not a package. Right? It points to a package, but it's not a package itself. Okay, does that distinction make sense? Yeah? Okay. So, let's do the uppercaseifying part. Okay. So, what basically what I want to redo is, and let me scroll this down so that we've got a little bit more room to see. What I want to do is rewrite this function, but using pointer notation. Okay. I still need to have a counter, right? Okay, no big deal. Okay, And I can still go ahead and do a while loop. And actually, you know what? I'm not going to do a counter. I'm going to show you guys why. I could do a counter, but I don't have to. Let's see what I call this. Input string is not equal to the character 0. Okay, well, that's true. And then this part, let me just copy and paste, and I'll modify some stuff. Okay, so what do we do? Oh, and I need a curly brace there, and I need to tab this over one. Okay, so then let me just finish typing it, and then we'll talk about what I'm doing. Okay, and what am I? Okay, I think we're good. Oh, and then I'm gonna, in the while loop, I need to add that. Okay, so let's change here, and let's just do it to use the second function instead of the first one. Okay, and let's make sure that it actually does the same thing. Okay. Oh, right. Okay. So I need to do. Okay. So same result in terms of how it worked or what it output. Okay. So let me actually change this back to that. Okay. So it still does the exact same thing. Okay. And so what I'm doing here, okay, is, so you'll notice that I've got the input string, input str. I'm using it in two ways. Okay. What are the two ways that you see? Or maybe it's more than two, and I just can't count. But how am I using that? Okay. So, well, the two sort of categories of the ways I'm using it is I have a star in front of it in some places, most of them, and I have no star in front of it here. Okay, so what's the difference? Right? And it's a rhetorical question because you guys don't know yet. I'm about to tell you. Okay, so the name of a pointer, okay, is a 64-bit value. Star, the name of the pointer, is the thing pointed to it by. Okay, so for example, let's take our package analogy. Your package is in mailbox number 7. Okay, and so if I, well, in fact, let me just type this here as a comment. Okay, so let's say that your package is in mailbox number 7. Okay, then I would have, if I wanted to make a pointer to it, I would say package star mailbox number. Okay, that would be a pointer to a package. okay? And the mailbox number would be 7, okay? So mailbox number is 7, okay? And star mailbox number is your package, okay? It's the thing pointed to if you put a star in front of it, okay? It's the pointer itself if you don't put a star in front of it, okay? Now, on the reverse side, I've used another notation before, which is if you put an ampersand in front of something, that tells you the mailbox number where it lives, right? So I can say, I want to know what's in a particular mailbox, or I want to know, hey, I've got an object, what mailbox was it in? Okay, I can go do either one. Okay, so does this kind of make sense? Okay, and you know, don't panic. Pointers are one of the hardest things to get used to in C. So like it's not going to sink in instantaneously. Okay, it's confusing at first. I 100% grant that. Okay, okay. Um, so in this function, what am I doing? Okay, I'm saying while. All right. So my input string. Okay, the pointer that I get is the pointer to the first character in memory of the string that I'm dealing with. Okay? And I'm asking, all right, is that character the thing pointed to the null terminator? Yes or no? It shouldn't be at the beginning because, well, we haven't gotten to the end of the string yet. Okay? All right. And then we just say, okay, if the letter in between lowercase a and z, yes or no? If it is, you know, change its ASCII value to be uppercase, otherwise don't touch it. Okay, good? Okay, and then, so that part we can kind of ignore for right this instant, right? But then the last thing what I've done here, input string plus plus, okay? What have I done? What have I changed there? What does plus plus do to something? Yeah, and it's not recursion because I'm not calling myself. This is still iterative, okay, yeah? Yeah, it keeps adding, it increments it, okay? It adds 1, okay? Uh, asterisk, which I'll explain. Sometimes it's more than 1. We'll deal with that in a moment. Okay. Uh, but what am I incrementing here? What kind of thing am I incrementing? Huh? A pointer, a memory address. So what I'm doing is I'm incrementing the pointer so it now points at the next mailbox. Okay. I'm not incrementing the package. I'm incrementing the mailbox number. And then when I come back around to the loop, I'm going to be looking at the next mailbox and looking at the package that's inside it. Okay, so does the distinction make sense here? I'm incrementing the pointer. Okay, now what's going to drive you guys crazy, and I'll show you an example of this in a minute, okay, is that if you increment that pointer, plus plus, what do you think it adds? So like, let's say that this input string was 7. What would be that plus plus? 8, right? But not always is it 8 for very good reasons. Okay. The reason it's actually 8 here is you have to also think about what type of data are you pointing to. In our case with the string, what is a string fundamentally? It's an array of characters, right? How much data does one character take? 8 bits or 1 byte, which happens to be the size of a mailbox. Okay, so each character only takes up 1 memory address. And so when I increment the pointer to go to the next character, I only need to increment it by 1 byte because that's where the next character is going to be. Okay, but what about if I had an array of numbers? Well, how much space does it take to store, say, an integer? not a character, but like say just an int. Do we remember? 32 bits, okay, which is how many bytes? 4 bytes, okay? So if I have an array of integers, if I want to go to the next location that has the next number, I actually have to go 4 bytes down the line, not just 1. Okay, and I'll demonstrate this in a minute. Okay, so you have to keep track of, okay, you don't have to, the compiler does this for you. The compiler knows what type of object you're pointing to and increments accordingly, okay, which is nice, but yeah, okay. So, questions, what questions do we have about this rewriting of the function? In terms of output and functionality, it's exactly the same. In terms of how it looks, though, looks a little different, okay? And in fact, here, let me scroll and put, you know what, I'm gonna do something cool. Let's put both of them side by side. Isn't VS Code neat? Yeah, so it's the same thing. I'm just gonna, left side's got the original function that I wrote, right side's got the new version. Okay, so questions, discussion. Which is better? And of course, that's a loaded term deliberately. Okay. You like the first one better. Why? Okay. You can see that you're iterating the count, and it looks, maybe it's more readable and makes more sense, like what you're doing. Okay. Is there any sense in which the second one's better? Yeah. True. Okay. Yeah, if the pointer changes the function, though, it'll be okay because car input string is really a pointer to the first character, so that would change before we called the function. Okay, yeah. So I think the better aspect of the right one compared to the left one is when I say car input string bracket, okay, if I said void uppercaseify int in, I'm passing it an actual integer, right? It gets its own little copy of in. So when I do this, does it kind of make you think that I'm really giving this function the entire string? It looks like that's what you're doing, but you're not. You're really giving it a pointer. So car input string bracket, that actually is a pointer. Okay, it just doesn't look like it to you. Okay, and this is one of the things about strings, right? Is that like it's kind of annoying to have to think about pointers, so you have this way of writing it that avoids the issue. Okay, but if we quoth the book, okay, so let me find this because let's see, where did he say it? Okay, so here we've got basically two alternatives. We have car input string empty bracket or car input string as a pointer. Okay, so they are equivalent. Okay, so this is at the very bottom of page 99, and yeah, as formal parameters in a function definition, that's what we're doing. These two things, the bracket version and the star version, are equivalent. Okay, we prefer the latter, meaning this one, the pointer version, because it says more explicitly that the parameter is a pointer. when an array name is passed to a function, the function can, at its convenience, believe that it has been either handed an array or a pointer and manipulated accordingly. It can even use both notations if it seems appropriate and clear. So you can actually mix apples and oranges here. Okay. And yeah, okay. So so all that to say, they're both valid. Okay. The second one is slightly preferred, okay, for maybe two reasons. One, what about if I'm passing a pointer to some other kind of object that's not as obvious how to work with as a string? We'll talk about those later. For example, they're structs. This would be like a compound data object. And two, it it I mean, he's right. It does make more clear that I'm really passing a pointer. I'm not passing the string. I'm passing a location of it. Okay. Is this distinction too technical for 8 in the morning? Yeah. Close. Huh? Well, I'm used to being up at this hour, and I'm not an 18 to 22-year-old male anymore. That ship sailed a while ago. When I was y'all's age, I could be up at 8 in the morning, but I was not happy about it. In fact, when I was in college, there was one year that 3 of my 4 classes were at night. That was weird. So I had like abstract algebra at 8:30 at night. It was 8:30 to 10 p.m. And that was like the only time, like that's just when you took it. Um, and that's a little weird. The reason for that is the school that I was at started as basically like a university where engineers at Texas Instruments could get master's degrees. So it started as a graduate only institution. Uh, and it had no dorms or anything because everybody was already a working adult. They had their own place already. And so, sort of the vestibules of this would be that some of these classes were taught only at night because that's when the engineers weren't at work. So, yeah. Um, anyway, so okay. Good. We all right. So let's look at another example of this pointery stuff. Okay, to make this sort of mailbox and address stuff maybe a little bit more clear. By the way, I actually found so I have a print copy of the book, right? And I think I put the link to the electronic version on Canvas. The library's got it. They also have a print copy that's on reserve if you want to borrow it. But guess what I found? The French version. Okay, so let's see what it says about the function thing in here. Yes, un temps que permettre formel dans une définition de fonction, car S et car star S sont équivalents. Nous préférons le dernier parce que qu'elle indique de façon plus explicite or plus explicite que le paramètre est un pointeur. Right? So, yeah, that's kind of a nerd moment. Yeah, well, I do, but so actually, I mean, this. Why did I buy that? Okay, well, that, but like, I know the book, I know C, and I know C in English, right? So one of the things that I've found really helps me develop my skills with the language, with French, is reading things where I know exactly what's going on in English, but reading it in French. Okay, and then what I gain there is technical vocabulary, and I know what they're talking about, and so I can kind of figure out the rest of it. Um, yeah, so that's why I bought it. It makes learning a little easier. Um, so okay, all right. So let's start a new directory here. and we'll do, oops, I don't want to put it in the strings thing. Here, I'll just make it out here. All right, so let's look at pointers 1, and let me go ahead and close this and close that. And let's create a new file, and we'll call this pointers1.c. Okay, so our usual things. Okay, good. So usual stuff. Okay, so let's also do a couple of things. Let's declare a string, and let's declare an int. Let's declare a bunch of different data types. Okay, so let's do int number equals 7. Let's do int, or how about a float, or how about a double? 3.14, and let's say let's declare an array, and let's declare a string. Okay, and let's declare a, yeah, so let's do an array, or sorry, a string. We'll do that one first. Car, my string equals hello. Okay, and then let's make an array. Okay, so how do I declare an array? Oops, and what do I need here? Forgot the brackets. How do I declare an array? And first off, well, an array of what? A string is an array of characters. Okay, so let's say I want to do an array of something else, like integers. Okay, so what am I building my array out of? I'm building it out of ints. Okay, and hence, if I could type, it's an int my array brackets. Okay, because it's an array of what? Of ints. And a string is an array of what? Of cars, etc. Okay. Okay, what do we want my array to be? Let's just do something like that. 3, 1, 4, 1, 5, 9. Or okay, just whatever. Okay, good. All right, and then let's just compile that, even though there's nothing going on. All right, so, oops, cd dot dots, and we want to go to pointers 1. All right, gcc pointers 1.c output pointers 1. Okay, and if I run it, well, it does absolutely nothing. Okay, because all I've done is declare some variables, but I haven't actually done anything with them. Okay. All right, now what I want to do is I want to define 4 pointers. Okay, so I want to do, what is number 7? The number. It has value 7, but it's an integer. Okay, and so what am I pointing to? Pointer 1, I want to point to an integer. So that's why I put int in front. Okay, and what is it pointing to? Well, if I just do this, where is it pointing? Huh? Yeah, it's not pointing at anything. Okay, we call this the null pointer. Okay, and it's not pointing at anything because I haven't pointed it at anything. I know that sounded really stupid, right? But I haven't initialized its value. It's just dangling there. Okay, all right. But if I want to point it to the number, what do I initialize its value to? Well, the number, the value, the variable here I've called number is, its name is number. Where is it? How do I access its mailbox number? With the ampersand, okay? So that initializes pointer 1 to point to that integer, okay? Wherever it is in memory. Yes? Okay. Similarly, for the others, well, let me do double star pointer 2, and I'll make that the address of number 2. Okay, and then car star pointer 3 is the address of my string. Okay, and then int my array, or sorry, not in my array, pointer 4 is ampersand my array. Okay? Okay, so I've got those pointers. So let's print everything just so we can kind of see where it all is in memory. Okay? All right, so I want to print, let's do printf, and I want to print the number %i is located at %p. And what do I want to pass that? Well, what's the number I want to give it? Number, okay. And where is that located? Pointer 1, okay. And it's not star pointer 1, it's pointer 1, okay. So what's the difference again between star pointer 1 and pointer 1? Star pointer 1 would have what value in this case? 7. Pointer 1 would be the actual memory address. Okay. Now, I know why this is confusing when I say that, because you say, wait a minute, Dr. C, you put a star there. So shouldn't that be the thing being pointed at? And it is. It's just saying, what kind of data am I pointing at? I'm pointing at an int. Okay. But when you use the pointer, star pointer means the object being pointed at. Pointer just means the pointer. Okay. Does that distinction make sense? It'll sink in, I hope. Okay. All right. So I'm going to print that, and then let's do the exact same thing for the for the other guys. So I'll just copy and paste it, and I'll say the double %f is located there, and what was this? It was number 2 and pointer 2. Okay, and now we've got a little bit of a problem, because can I print the entire, well, I can print an entire string. Okay, so the string, let's put some quotes around it just to make it look nice. Okay, and so this was my string, and it was pointer 3. Okay, but then the array, I can't really print an entire array. I mean, I could, but I'd have to print it sort of one integer at a time. So let me just, for the sake of demonstration, the array is located at, well, actually, here, let me do it this way. Okay, so let me just say the array that starts with this number is located wherever. Okay, so I'm just going to pass it the first integer in the array and not the whole thing. Okay, okay, good. Question, Patrick? Okay, because all I'm going to do is print the first number in the array, and I just picked that just so I can print something, right? I'm not passing it the whole array, I'm just passing it the number that's in the first entry. Well, I can't pass it the whole array. What I can do, though, is pass it a pointer to that array, okay, which we'll look at in a moment, okay, because, yeah, that's a fair question. Okay, oops, so let's compile it and make sure I didn't screw anything up. Right. Right, okay, so you've got to do this. Okay, that's a technical distinction, and I'll explain why later. Oops. Oh, okay, sorry. You don't actually have to do this for strings and arrays because their name is their pointer. The bracket thing, I'll come back to that in a minute. Okay, so let's run it. Okay, and what do we see? Well, we see that the number 7 is located at whatever, the floating point number is located over there, and so on and so on and so on. Okay, great. Nothing particularly exciting about that, right? But we can see that these things are all in memory, okay? And what I want to do, though, is let me recompile this, but let me add in the static and the debugging stuff, okay? So that we can go through GDB and actually look at all of this stuff in memory, okay? All right, good so far? All right, so let me open up my terminal and okay, so I'm going to put a breakpoint at main, and I'm also going to put a breakpoint at line 19, basically after most of this printing has happened. Okay, so we've initialized a bunch of things, we've printed a bunch of things, great. Now let's look at, in memory, okay, what's the smallest of the addresses that we see? EF50 looks like it, okay, which happened to be the last thing that kind of go in reverse order. All right, so let's examine memory starting at 7FFFFF EF50. Okay, and let's see what we see there. All right, so what do we see in memory? The very top left is starting at blah, 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 50 is the addresses. Well, what do I see? Three, 1, 4, 1, and then 5. Okay. And how much data does each of those numbers take up? So this 3 that's in this box, okay, really it's in 4 boxes, okay, because an int takes up how much data? So what's the size of an int for us? How many bits? 32. Character is 8. Okay, so an integer requires 32 bits or 4 bytes worth of data to store, and it just so happens that this thing is displaying it in 4-byte chunks. Okay, and then each row therefore is 16 bytes. 4 times 4. Okay, all right. So the first box, or actually the first 4 boxes, the very, very first one has a 3 in it. The rest of them are zeros, and so the sum total is just a crap load of zeros with a 3 at the end. Well, that's 3. Okay, same thing with 1, 4, 1, and then the 5 that's next. Okay, is that okay? Yes or no? Okay, all right, where was the string located? Let's just work our way back. The string hello is starting in EF68. Okay, so EF68 starts here. Okay, and what was our string? What did I type? Hello? All right, well, 48 is what? H. 65 is, 6C is L, L, O, and then 21 is what? The exclamation point, and then there's a 00, that's the null terminator, right? That tells me I've hit the end of the string. Okay, good? Yes? Okay, what other variables do we have? Well, we just started at the bottom. Okay, so the array, we looked at the array and the string, And what about the double? Where was it located? EF70. Okay, so that's here. Okay, this one's a lot harder to read. Okay, you can't just read it off because so a double is how much? What's the size of a double? Double precision floating point. It's 64 bits. Okay, so that means that it's going to be that number is in the sum totality of it is this. Okay, so 51EB 851F 40 blah blah blah. You look at that and you say, okay, how the heck is that 3.14? Is it obvious that that's 3.14? No, not at all. Okay, and the reason is, well, how are floating point numbers encoded? Pray tell. Some of you guys did this with that took you guys that suffered through CS101 with me, right? Remember we talked about IEEE 754? We'll come back to that for the rest of you who don't know it because I want you to know it. Okay, but point being, that is 3.14 just encoded in the way that floating point numbers are encoded. Okay, there's a standard for this. It's called IEEE 754 that defines a standard way to encode floating point data that we all use now. Okay, there didn't used to be this standard until the mid 80s. Okay, and so different systems did floating point numbers different ways. But now we all are one big happy floating point family. Okay, so you just have to trust me that that's 3.14. In fact, actually, I can show you. Huh? All right, so let me change this to, what did I make it, just 3.14? Okay, so you see this? Does that look familiar? In fact, four zero zero nine 1EB8 51EB 851F. Ba-bam. Okay. Yeah, so it really is 3.14. Not obvious, but it is. And we'll talk about that IEEE system of encoding later because that's something you guys need to know. Okay, good? All right, and then the easy one, the last one is what? What was the integer that I picked? 7. What was its location? 7C, and there it is right there. Okay, that 32 bits worth of stuff. Okay, okay, so it's all in memory like you would expect. Okay, so let me quit this and go back to our code. Okay, and let me, for now, let me just delete and not worry about the number, the integer, or the float, and let's just concentrate on the string and the array. Okay, and I'm going to change my print statements to not print the entire array, or string rather, but just a single character. Okay, and so I can do printf, okay, the character located at a pointer is a character, okay, and then where is the pointer? Well, who is the pointer? It's pointer 3, okay, and what character? I can actually do pointer 3 for both of them, okay, because what does pointer 3 point to? Yeah, okay, so I want to point to a thing, though, so that means I need to put a star in front of it. Okay, so what's the difference between pointer 3 and star pointer 3? What is pointer 3? What is that object? Like, what type of thing is it? Nope. It's a memory address. What is star pointer 3? The thing pointed to by the pointer. What does this pointer point to? Points to a character. Okay, so that's why I had to have, and what the order I printed them, I put the pointer first and then the character second. I just picked that arbitrarily. Okay, no particular reason. Pointer first, character second. Pointer first, character second. Okay, so let's run this and make sure it runs okay. Oh, okay. What is it? Oh, not print. I meant printf. Sorry. I know. Just worthless. Okay. So what did I call this? Pointers. Oh, and I need to put a line break here so it's easier to read. Oops. Okay, so the character located at blah, blah, blah is H. Great. That makes sense. That's the first character in my array. Yes? Or my string. Okay, so good? All right, for my next trick, okay. So what did I just do here? I shifted the pointer by 1, and if I point to, so if the H is in mailbox number 7, and I add 1 to the mailbox number, I now have mailbox number 8, and what should be in mailbox number 8? The lowercase e, okay? So let's see if that's in fact true, and it is, okay? And notice, what's the difference between blah, blah, blah 98 and blah, 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 oh, wait. Sorry, okay, it changes. Sorry. Okay, so you notice that the memory address wasn't exactly the same each time I ran the program. That's going to be the case. So you can't compare memory addresses between subsequent executions. You can only do it within a current execution. Okay, but so where did the thing start in memory? It would have started at blah, blah, blah 588. Okay, but where's the second letter? One down at 589. Okay. Mm-hmm. Oh, yeah, let's just do that. Okay, so in fact, let me just copy this and print and tab it, and then let me just not add 1 here. Okay, I think this is what you're getting at, right? Okay, so if I don't add 1, that points to the beginning of the array, its first character, the H. And then if I add 1 to that pointer, I'm now pointing at the second character in the array, which is the E. Okay, make sense? Yeah. Okay, so let's do the exact same thing, but with our array of numbers instead of our array of letters. Okay, so I can copy paste this, and we'll make a few changes. Okay, so that dealt with the characters. Let's deal with the integers. So I have to change this. Well, we're no longer talking about integers, or characters, excuse me. We're talking about integers. And it's pointer 4 this time, right? Because that's just what I called it. Okay? And then same thing for this, the integer located at that is pointer 4 plus 1 and pointer 4 plus 1. And then what do I have to change the %c to? because I'm no longer printing a character. I'm instead printing an integer. So this should be percent either I or D, okay, or X if you want it in hexadecimal. I'll just take it as do I. Okay, so exact same syntax basically, except I'm printing an integer in its location rather than a character in its location, and I'm incrementing that pointer or adding 1 to it and looking at what's essentially 1 box down. Okay, does that make sense? All right, so let's run it and see what we get. Okay, so what is PTR4? What is that value? That value is the pointer of to the first number, which is, the highlighting maybe isn't too easy to see, but it's the third line from the down that has the is 3, right? So blah, 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 B0. Yes? What's the address of the next integer in my array? What's it say? Blah, 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 B4. But wait a minute, Dr. McKinney. What did I add to my pointer? But this is like I added 4. Last time I checked, 1 and 4 are not the same number. So what the hell's going on? It's 4 bytes. Okay, why did it increment by 4 bytes? Because how big is an integer? 4 bytes. So if I want to go into the next integer into an array, how many slots down do I need to go? 4 of them. Okay, but I could type +1 here, and the compiler knows, because I declared it, that what kind of thing is pointer4 pointing to? It's pointing to integers. Those take up 4 bytes, and so when I type +1, it's like, oh, he's incrementing by 1, but because the things he's pointing to are integers, it really needs to increment by 4. And it sorts all that out for you. Isn't that nice? Thank you, GCC. You the real MVP. Okay, yeah, I know that one was kind of bad. Okay, yeah. Put +4. Oh, okay. So, yeah, like let's say that I did something like this, right? If I try and outsmart the compiler, right? Okay. Yeah, can't do that, right? It's going to catch that. So, yes. So that doesn't work, okay? Trying to outsmart the compiler. But let's say that I put, oops, I need a +1 there. Let's say that I put +4 here and +4 there, and I'm trying to, again, outsmart it. What do I get? It's 16, okay, but 4 times 4 is 16, and most importantly, what integer is there? The 5, because what was my array? 3, 1, 4, 1, 5. Yeah? You guys don't seem convinced. Hmm? What do you mean? Oh. What's the difference between blah, 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 40 and blah, 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 50? It's 16 because that's in hexadecimal, right? Mm-hmm. Because what's 10 in hex? 16 in decimal. Yeah. It really is kind of cruel to put this class at 8 a.m., isn't it? This is way too technical for. Maybe I need to have like a pot of coffee over there for everybody. You wouldn't turn that down? Mm-hmm. Okay. All right. So why does it do that? Well, what the reason I think that they designed the language this way is because it allows you to not have to worry about how big the object is as you're incrementing through multiple of them. You just type +1 to mean the next thing. And the compiler sorts out for you how many that is. Okay, if it's 4 bytes or 1 byte or whatever. Okay, and in fact, we can sort of demonstrate this in another view, which is, let me just change this back to +1 for the moment. Oops, forgot the output. Okay, so what I just had this do is, and this is not 6502 assembly, it's ARM64 assembly, is I had the compiler output the assembly for this, which is one step along the way. Okay, and let's go to where the print statements are. Let's go to our last print statement, which is Okay, right there, added 4. Okay, there's the 4 bytes. Okay, but before the previous print statement, it only added, well, it didn't add anything because I didn't tell it to. Okay, but before the previous print statement to that, it actually added 1. Right? And it makes sense. Characters are 1 byte, arrays are 4. So we typed +1. The compiler was like, oh, what he means is the next integer. That's 4 bytes down, not 1 byte down. So there you go. All right, now, does that look like a bunch of gobbledygook? Yeah? I can't wait for us to start in assembly. Eventually, you guys will be programming directly in this gobbledygook. Yeah. You know what makes it even more fun? Doing it at 8 in the morning. Yeah? Okay. Hmm? Yeah. So, okay. So, let's go back to our code here to the C stuff. Okay. And I do want to make one other distinction here, which is I could do this. Okay, actually, hold on. Let me make sure that I've got the syntax correct here. So, okay. Hang on one second. So the distinction I'm trying to make here is I can have, yes, okay, that's right. I need to do, is that thunder or the trash thing? Okay. Okay, so let me just say this, okay? So that here I would say and my array. All right, let me make sure I've got the syntax good. Let me go back to the GCC. Okay, good. Okay, so the distinction here between pointer 4 and pointer 5, okay? Pointer 4 points to what kind of thing? it points to an integer. It happens to be the first integer in an array of them, okay, but it points to the first one, okay? And we saw that. The second thing I wrote here, pointer 5, okay, this points to an array of 5 things, okay? So, let me demonstrate what I mean here. Oops, and let me put in a line break. Okay, and let me just, for cleanliness, let me just comment these out so that we don't. Okay, so what does pointer 4 point to? What is pointer 4? It points to the first integer in the array, which we can kind of take as being the array itself. So that's where it starts, okay? But it's pointing to a single integer, right? Okay. The second one, pointer 5, is pointing to an array of 5 integers, okay? So how much space does it take to store a single integer? How many bytes? 4, okay? Therefore, how many bytes does it take to store an array of 5 of those things? 20, right? 20 bytes. Okay, so if I increment a pointer that's pointing to an integer by 1, how many memory addresses down the line have I really gone? I've gone 4, correct? Okay, and in fact, let me actually add a couple of things in here. Let me add this in so we can see actually what the pointers are. And then I'm going to do the same thing for the next one. But I'm going to make it pointer 5. So we'll do the original and the original plus 1 for both of them, okay? Okay, good. All right, so what did pointer 4, what was its value? Blah, 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 7, 8. Yes? Okay, so it's just some location in memory. And pointer 4 plus 1 is really plus 1 more integer down the line, which is how many bytes further on? 4 bytes, because that's how much integers take. And what is pointer 4 plus 1's value? Blah, 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 7c. Is that 4 bigger than 8? Yes. Okay, right? Because 8, 9, A, B, C. Right? Okay, all right, so that jives. Good? Okay, pointer 5, what's he pointing to? The beginning of the array, okay? He's pointing to the array, which is, well, it's the same array, right? And so its address or its value is blah, 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 7, 8 still. It's the same array, okay? But what's it plus 1? Blah, 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 8c, which is how much bigger than blah, 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 7, 8? Pray tell. Well, okay, let's do the arithmetic. All right, so we started at 7, 8, and we ended at 8C. Thought arithmetic was fun, right? What's C minus 8? 4. What's 8 minus 7? Okay, now this is in hexadecimal. So 0x14 is equal to what in base 10? 20 in base 10, which how big is an array of 5 integers? 20 bytes. Okay, so the distinction here is pointer 4 is pointing to an integer. Pointer 5 is pointing to an array of 5 integers. Okay, now why might I want to point to the array rather than the individual integer? Okay, well, what about if I want to do something a little bit more devious, like a multi-dimensional array? Okay, could I have an array of arrays, basically? Right, and this is one way I could think about them. Now, why would you ever want to have an array of arrays? Huh? Well, okay, a dictionary would be, when you say dictionary, what do you mean? Like you look up words in it, or the other kind of, yeah, the other kind of dictionary? Yeah, which you guys will talk about, like data structures and stuff. Or what about if I wanted to write a program that did like linear algebra, like matrix stuff? Okay, well, then I would need arrays of arrays because that's what a matrix is, right? I've got rows or I've got columns, just whichever way you want to think about it. Okay, could I do that? Yeah, okay. All right, so that's maybe pointers in a nutshell, and I know that's kind of blech. I'll come up with some torturing, arduous assignment to make you, character build you. And then we'll talk about structs on Thursday, which is how you do compound data types, and pointers will be eminently important to that. So I hope that you found this illuminating all the myriad of things about pointers that I've pointed out to you today. Okay. Pointers are worse than pledgeship. Okay. Yeah, that's harsh. All right. See you guys.